Hello, this is Russell, K5RUS. It's time for another NXP RF design challenge. This time we want to submit the new MRF101AN. This is a true LDMOS RF FET in a TO220 package. Small, inexpensive, runs about $20 in small quantities for most distributors of NXP products. NXP provides these RF Essentials kits, which is basically a design resource, and they supply you with everything but the frequency-dependent components that you need to produce a test amplifier or demonstration amplifier based on the datasheet information. I acquired a couple of these Essentials kits and built up amplifiers, very easy to do, and was quite surprised with the performance of, typically when you see these TO220 package devices, they don't always perform very well, much above the HF or low VHF range. NXP's done a great job of actually get quite good power gain and efficiency up into the high band VHF range. So after building up one of the Essentials kits, I decided to make my own board. What I did was port the printed circuit board artwork from .090 thickness FR4 board material down to .060. I had to make the board at home on the PCB router and make it from scratch. The circuit actually worked quite well, so NXP's done a good job with the input and output matching on this device. So I took the liberty of incorporating the thermal tracking bias circuit, which they recommend in the literature on the RF Essentials kit, into this board. Also included a Pi network input attenuator. Did some calculations on the design to use common resistor values. The logic here is that you can take just about any exciter RF power that you may have available and customize the input so that you don't deliver more than a half-watt drive to the gate of the MRF101. The entire project is mounted on an aluminum plate just to make it a complete pallet amplifier. Range from 24.5 dB to 22.5 dB over the entire range of powers and frequency. Efficiency was really good too. Once you start getting up into the 50 watt and up range, 60 watts and up, runs about 60% to 70% efficiency. Total drain current draw from the power supply maxed out at about 2.6 amps at 50 volts. So in closing, I'd like to just make a couple notes, just some thoughts I had on the use of this device for portable use. It's when we use something portable or in the field, it's sometimes exposed to elements that you may not encounter in a fixed environment. You may have an opportunity to destroy the device due to mismatched loads or power issues or what have you. Being this device is inexpensive, becomes feasible to change it. It's also easy to change because it's a very common package. A single screw holds it down, and the way the leads are, it's not near as challenging as, say, a true RF ceramic package device. So with the low cost and it's easy to work with, would make it easy to maintain it, to change it out. One turnoff to it might be the fact that it's a 50 volt device, which is actually probably one of the reasons that it's works so well, especially even in a single-ended design, is that the output impedance is more reasonable compared to, say, a 12 volt device that you tried to push that hard. It becomes a little bit easier to match. But there are a lot of inexpensive boost inverters out there that could be used to supply the 48 volts, say, from a 12 volt supply, and still keep the total current draw around 10 to 12 amps at 12 volts. So it would be on par with an 80 to 100 watt class amplifier in the 12 volt range. But the gain is so high, you would omit the need for driver stages in those type things. So neat device. I look forward to playing around with this thing some more and seeing what else could do with it. It's a linear device. It's not just for Class C applications, which works equally well for that. So anyway, NXP's done a good job here, and there's also a big brother to this device that has even more power and a slightly larger package. Again, inexpensive and easy to work with mechanically. So anyway, thanks for watching, and if you get an opportunity, pick up one of these RF Essentials kits, build up one of these amplifiers. I think you'll be pleased. It's a neat product.